All right. So basically, what we had seen in the previous lectures, the previous week, is that we started basically studying that magic is in not in the AI, magic is in the data. That is, you start finding patterns everywhere. This is the whole idea behind AI. Like we are trying to detect those patterns, and this rule holds uh, true and up for I have seen for almost all kinds of data. You know, uh, it is a human limitation that we are not able to find the patterns properly, but the relationship exists because I'm what I feel again. I did not read it anywhere, but this is just what I feel that since uh, nature works in evolutionary manner, it evolves, it keeps on evolving from one form to another form. And we also have an evolutionary algorithm inspired from nature, which we will discuss this time. In the previous batches, I did not discuss few things. In this batch, I will discuss those things. So whatever those things, evolutionary algorithm will discuss. So it works in evolution, and evolution, once it is working in evolution, it cannot happen in absolute randomness. It cannot be randomness. It may seem to us randomness, these flowers, all of these things, they may seem to us random, but they're not random. And magic is in the data. Always, I have been saying that magic is always in the data. AI is just a lens to capture it. And we did see a few examples also. These are very high level examples that obviously in nature it has been happening ever since. But yes, there are a lot of things in nature that we don't even understand, right? And the flow remains very simple that basically this we still have to discuss in great detail. So I will not go on this slide as of now. And then we discussed few case studies of how finding the data patterns during World War II helped us in uh, deciphering the cryptic messages from Germans, how they helped us. And then basically we also discussed about a case study of how, you know, Dr. Snow solved the problem of, I mean, it was just a mathematical solution just to restrict cholera breakout. So many such traditional examples are present, and we have these applications across lots and lots of fields. I so I also decided a few months back that let me try to apply this complete theory in something that uh, not many people are doing. So I thought that let me now base out my complete application or startup based on financial markets, and let me try to do something around it. And again, like I said, I have earlier also stated, I worked on the same theory and principles that I'm telling you, that there will be relationship in the data, and this relationship might be very complex for us to understand. So sometimes we will have to use the right tools, and sometimes working with the data hours, not just hours, days and months, sometimes working with the data, just observing how the data is behaving. And same theory is true for any of these fields: retail and commerce, manufacturing and engineering. I mean, in engineering, obviously, there is a lot in basically studying how the disease spreads, in crime, medicine, and genomics. In all of these things, the same theory applies. Just the tools will vary. Now, all of these tools we will be discussing this time. And these are some of the tools. These are some of the tools. Now, do not be surprised by these fancy names. These are just fancy names. These are relatively simple concepts. What I commonly, even when I did not knew AI, that is back in 2008 and 2009, and I started scratching. My first application that I delivered in AI was back in 2013, basically. And in 2012 or something, when I was reading about these things, there was not a lot of material present over there. So when I started reading all of these concepts, these fancy names, regressions, and stochastic gradient, gradient descent, and all of these fancy names and very you know good terminology, I was also considering that these might be very very complex. But as you go on learning, you realize that these are very logical things. Under the hood, these are some common uh, some common concepts that are present, not very complex things. However, it's wrong to say they're not, everything is not very simple, but yes, I mean, when we try to understand them logically, they're not as complex as they sound to be, right? So this was what we discussed previously. This time, what we are trying to explore today, what we'll be exploring is something completely new, and something that lays down the foundation of modern AI. This same concept will continue to discuss throughout months, but through different algorithms, through different data, for images. When we try to generate new images, eh, we have mid journey that generates wonderful images. We have AI model that generates videos, and then we have that models that generate texts, and there are some models that just give us the forecasting. So there are just different kind of models. Right, I'll just switch. Just give me a second.
Can you start the recording, Anand?
It's already started.
Oh, is it? Okay.
Yeah, yeah. All right. Now, if many of you come from various backgrounds, you may come from various backgrounds, right? You may be coming from, maybe you have been developing softwares and again developing softwares in various fields. Like, it may be, you have been developing softwares for finance, it may be for finance, or it may be for even for retail, banking, or many other things, retail, banking. And the aim is basically you want to innovate something in your field, you want to do something innovative. Obviously that boosts up your sales and brings some monetary benefits to you. So this is wherein we put all of the hard work. Now, traditional way of doing, and in fact lot of uh, this will continue to happen. Lot of the logic is based on rules. Lot of the logics that we work in day to day life is actually based on rules. Rules as simple as, I mean, you try to understand uh, any scenario, any existing scenario. Most of these things are based on static rules, fixed static rules. And many a times, even when you say that, okay, you have to give the requirements, and human brain actually loves rules, fixed static requirements. So human brain loves this. Basically, you talk to anybody, you try to explain them, they say that, okay, you do one thing, you give me these rules in fixed number of points, you just break them down and I'll stick to them. Right? It's easier for human brain to understand those rules. If this happens, then this should happen. If this happens, then this should not happen. Let it be in your real life, let it be in your any of these industries you have been doing, finance, retail, banking, all of these things we have been applying rules. Now, there are two problems that usually jump in with building your logic around the rules or building your solutions around the rules. Now, like I said, rule building is again a different science altogether. Now, rule building is not something to underestimate. When you actually build a lot of rules, some machines like finite state machine line, again a new fancy concept, but finite state machine, all it means is basically a system that has lots of rules, that's of lots of complex rules together, right? Simple one. just a fancy name, right? System with lots of complex rules together, working together. For an instance, you can say that the state, uh, the state, Maharashtra state or the Gujarat state, right? It is ruled by a set of rules, set of complex rules. So yes, it is a finite state machine, right? As simple as that. These fancy terms are very good to use when you are speaking in public, but obviously, when we are trying to express the real meaning, the simple terminology is far better. Right. So finite state machine, like I said, I mean, rules are nothing to, so this, why I'm telling you this, when you go forward, obviously you can build your application around complex set of rules or AI. There is the difference between if you're trying to build your application around complex set of rules or AI. Now, like I said, I mean, building complex set of rules, uh, especially if you're trying to put it in some software or something, right? It requires some very specialized skills. I have seen programmers even struggling with trying to put some extremely complex rules, especially when they are interdependent on each other. When they are interdependent, that rule 1 is dependent on rule 2, and also it is dependent, and rule 2 may be dependent on 5 other rules, like R10, R15, R17, and these kind of complex relationships occurs in various industries. Not to mention, like, many of you might have already seen these kind of complex things. uh, Already few people working in CPQ domain and all of these domains. I mean, the complexity is not new to them. So all of these complex system and these set of complex rules occurs, and some of these rules become so wildly complex that sometimes the complete system starts to misfire. So sometimes it starts to misfire or do something like that, right? So again, rules is there, and the second one is there, that what you do is you allow AI to make all of these rules, automatically, right? You allow AI to make all of these rules automatically. That is, it will automatically try to learn rules from the previous data. It will automatically try to learn rules from the previous data. Now, also, there is problem, with these kind of systems. What is the problem? The problem, if you see, now, again, I said, when you design a system, you have to be very mindful if you are going to build your system around rules, or if you want an AI, right? I'll also introduce you one more scenario. Actually, now I want to differentiate between AI and, this is AI itself, but nowadays people AI with LLM, right? AI with LLM or any heavy model, right? Uh, so just talking about a very real scenario that I faced back in 2019, and again I started, actually, every data analyst or every AI developer that is working on any problem, they will face this problem. So let's say there is a problem, right? There is any problem and it can be solved via something. So I'll be very specific to the problem. So back in 2019, there were not too many applications. Basically, now I'm talking about, so back in 2019, I was heading a team that initially delivered the very first application around AI based financial document scanner. Now, nowadays, if you see around LinkedIn, it is filled with all of the post financial document scanner. So basically, you just dump your document toward the AI and it will pull up all the relationships. Not just that, it will basically put it inside the database also. Right. So this was the application we released back in mid of 2019, and that was a big one. In 2025, you see lot of LLMs trying to do this. Mistral has released a specific model, very specific to this only, and then there is a recent one from DeepSeek that they have released very specific model to this only. Back in those days, basically what I did was, and again, like I said, the problem that comes into picture. It is not that. we could have used very heavy models, GPU also. But if you are running short of funding, not every company will have millions of funding to run a model. That is, you know, so what happens if you have AI, LLM, or basically I can name it as heavy AI, heavy AI. So you always want that your model should run maybe it should use some rule based, plus it should use some lightweight AI. It should use some lightweight AI. Maybe lightweight in the sense it runs on CPU. I mean, uh, this is something new that even the new leaders jumping nowadays, when I talk to them sometimes, they feel amused that is it possible that AI runs on CPU? AI does runs on CPU. Lightweight AI are designed that specifically task that specifically solve a certain task, and they just run on the CPU. So you don't need to burst your GPU out, right? So back then also we had the problem, and then GPUs were actually more costly as compared to today, because GPU systems, obviously setting your own server may be feasible for testing locally, but when you want to cater to customer, you will have to rely either on GCP or AWS or Azure or something like that. So AWS was not very cheap. AWS was actually more expensive on GPU part as compared to today. So always you have some this thing that you built an application. Nowadays what is happening, why all of these lot of AI you hear you losing this money. This simple application that is running since 2019 on CPU, not even using GPU, right? And it has created revenue, lot of revenue and everything, and it has been running on simple CPU. It has been running on set of rules, and it has been running on set of light models. There is not one model involved, that there are some set of light models involved, right? And then either second option, what you can do, you can just go and hook it to your and by the way, even today till even comparing today, the accuracy is far better than LLM. The accuracy is far better than LLM. It can be customized from UI for a specific customer. That is, there is customer one has specific requirement, customer two has specific requirement, customer three has specific requirement. So it can be basically the model can be influenced. Again, use the word influenced for specific customer, and it can be influenced for specific customer. And again, going back to this thing that AI LLM, the other option, what people are doing, you have an LLM API, just go ahead and throw everything at the LLM API, and at the end it keeps on running in the loop. It keeps on running, and your people are, what happens down the line when we go ahead and study LangChain, we start seeing that these workflows become so complex that they are so hard to debug. So what happens many a times, some of the use cases might go untested. There was just a recent post on LinkedIn that what they had done is basically they had used the large language models in a way that they were asking it, and if the answer was incorrect, they were again judging it through the same LLM. They were judging it through same. If the answer was incorrect, it should again go ahead and try again, right? Now there was one certain use case which they did not test it. As a result, it kept on going into the same loop, and it kept on going into the same loop for 3 days. A really dumb architecture, right? It keeps on going, it kept on going into the 3 days, into for 3 days into the loop. As a result, the cost that they occurred, that would have been idly less than $10, right? Even if you have to do it, even if you do it properly, the cost, and they had to end up paying $30,000. $30,000, right? So, and this is just a recent example that I'm taking. Again, the source is from LinkedIn information, right? But yeah, I mean, these kind of mistakes I have heard going out in my circle, although I was very careful about spending money, because obviously in startups you have limited amount of funds and everything. So the question mark will always be, do you want to go with just rules? Do you want to go with a custom lightweight AI? Now this thing is actually completely disappearing because people now don't even understand how to build this lightweight AI. Or you just want to hook yourself to some LLM model and you are done. You know, you just want to hook yourself to LLM models and you're done. Obviously, this is what most of these cloud providers will prefer, that you should not know, or in fact, you know, you should not pay attention to building your small custom AI or building your small models. You should directly hook your problem to LLM, and you should keep on paying. Uh, you should keep on fueling money on these GPUs, and then in turn, your cost of product also increases. So basically, if you end up paying more to these servers, so at the end of the day, the cost of product will also has to increase, and your margins will also be less. Your margins will be less. So, uh, like I said, there is always this is always the ongoing tussle, and this is the aim of this course. When I say applied AI, we will be going through, we will be building these models from scratch. I really do not, I'm not really against LLMs or something, but I am against an AI that you do not own, that you do not own. Now, let's say this is again just one more example, that let's say you have just stitched your product to some LLM, large language model, to some Gemini or Chat GPT, and Gemini and Chat GPT, what they decide is, they decide to upgrade the model. They decide to upgrade the model. Once they decide to upgrade the model, your API response is going to change. Your API response is going to change. And there might be a chance that something that was working earlier may not work today. Again, like I said, this is the word of LLMs. I am not against LLMs, but yes, I am definitely in favor that you should know when to use these LLMs, when not to use these LLMs, when only rules are enough to serve your purpose, when only a lightweight AI is enough to serve your purpose, and when only and you have to just hook it through the AI LLM. Now, one more example I would like to bring, although I will be actually releasing a small paper around it next week. So basically, like I said, what I have been doing in previous 6 months. This is again something that an example of 2025, and we are soon stepping into 2026. So just a proof that all these rules still hold truth. I mean, this is not some AI of 2014. So again, I was actually what I do as of now. Like I told, I sell services for financial forecasting instruments, especially around forex and cryptos. So this is what I do. And again, I had the LinkedIn is filled up with all of the posts that DeepSeek is able to do that, DeepSeek is able to do this, and all of those things. Again, everyone is just trying to force the problem into LLM, right? And the problem before me was, I do, I if I'm not first and foremost going ahead and raising a lot of money, right? Saying that, I want to build this and give me some $10 million or $5 million at least, right? And obviously, raising money has cons. Everyone sees the pros, but it has cons. They are going to take away the IP of your company, right? So it has cons. Obviously, if you're trying to innovate something, first you should try to build a proper business model. That is important. So again, I had a problem. I don't want to burn my models on GPUs and everything, right? So although I what I did, I again started exploring around. I again started building an AI, that is lightweight AI and everything, right? Okay, and I built that thing, and we tested it, and we did deliver it to uh, we delivered it properly. And again, working on very low GPU, not I did not force every problem to LLM, right? So again, but rules versus lightweight AI versus heavyweight AI. We will always have this tussle whenever you will be going ahead to create a model. There are a lot of factors we will discuss further on it. What are those factors that we'll have to discuss? But rules have problem. That is, rules will expire in the sense that, let's say they were working in 2024, then will it work in 2026? They will not, right? In fact, there might be a chance in even in 2025 next quarter they might not work. The same rules may not work, right? The season has changed. Maybe it may be for, your rules may be for retail, your rules may be for anything or anything. uh, the season changes, the data changes, and everything changes. And then what you end up doing is you again have set of rules. You will have to change the rules. You again will have to test the application, and then you will have to release the application. So basically, what happens? A lot of time and money is spent on all of these things. Whereas if AI done properly, what is the advantage? You built only once. The program is built only once. The program is built only once. Now, it may be that this was trained, my AI, right, was trained on, let's say the aim of my AI is to forecast that which product, for let's say for a retail, that which product will be sold in next month, right, based on previous behaviors. And then it may be from small items, kitchen items, to big items, refrigerators, television sets, and everything. I want to forecast. A very simple example I'm taking. I want to forecast. So let's say if I am taking some rules now, let's say, and suddenly COVID had hit, or suddenly something else happens. Now, if this thing happens, obviously these rules are not going to. Obviously, now COVID is an anomaly, but we can have imagine of certain other condition that, let's say, the rainfall was much more in this year as compared to the rules you applied to previous year. Rainfall was much more, or the heat was much more, or the temperature, the winters will are going to be very fierce, or they are already fierce, let's say, right? So all of those conditions that keep on changing, and change is constant. Change is the only constant that we have, right? It keeps on changing. So what happens? We have the data one on which it was trained. Okay, fine. We had this AI version 1. Now, either you, since you do not have the new data, so whenever the new data comes in, you don't have to change the program. You just have to rerun the whole program. In the sense, you just have to kind of recompile or retrain it. Now, retraining doesn't mean writing in a single line of code, right? Retraining just means you have new data, and you just send your data to the AI, and that's it. It is ready with the AI version 2. So obviously this is more dynamic, and if you now if you combine data 1 and data 2, it will automatically, the new AI is ready for both these kinds of situations. It is ready for both these kind of situations. So obviously, and humans have limitations. We can only write certain amount of rules. We cannot write some unlimited amount of rules, right? We can only write some certain amount of rules. Obviously, with AI, what happens? It keeps on learning, and it can learn lots of rules. It can lots of rules, lots of conditions. It can learn lots of rules and lots of conditions, right? That is, in fact, I it is impossible for humans to learn, for impossible for human to figure it out and even put it in a software, right? It is impossible, absolutely impossible. Some of the rules are so complex, it is absolutely impossible. Sometimes it's even hard to find out how did it learn actually. It becomes a black box many a times, although there is a regular research that is going on to find out that how it is happening. We try to understand, but it is trying to sometimes it learns in very weird manners, and this is where sometimes it feels magical. But yeah, obviously, being we trying to understand AI, there's nothing magical. Basically, there is actually a mapping happening inside the data, which we will just see today. So what is happening? A new dynamic learning is happening. What is happening? We all see a dynamic learning is happening, right? uh, with rules we had static learning. With rules, what we had is we had static learning, right? Even now your application has learned, but those are some static set of rules. Now with AI, obviously the rules are dynamic, and you don't have to worry about uh, how you are going to teach the rules, but it is not a magical pill. It is not that you just throw the data, again, like I'm saying, it is not that you just throw the data and it will automatically figure it out. One rule of thumb is that mostly, that if you know that manually, you know that this data can work, there is some relationship around the data, 80 to 90% of the times AI is going to learn that thing. Now you know that this relationship exists, but you do not, the relationship is so complex that you might not be able to put it in a program or a software. I mean, it is just impossible for someone to do that. Now, an example is very simple. You see it in your cell phones, that an object eraser. Samsung phone has, or Apple phone has, this feature that you select an object, right? You select an object, and then there is some person standing here, and you select an object and you just hit that delete button, and it not just deletes it, it actually syncs it with the background. It syncs with background. Now, can it be done through Photoshop? Yes, obviously it can be done through Photoshop. It is a manual work. It can be done through Photoshop. Now, basically, this is something, it requires a special skill, right? It requires a very special skill. It can be done with Photoshop. But again, so AI was trained for that skill. That was already happening with some manual work. So AI was trained for that specific skill. And once trained properly with good amount of data, it is able to mimic that skill. It can mimic very complex things. So yes, it can do that. Obviously, now they have attached these features. Gemini has attached these features into its AI, but it is not that same. AI is not understanding text as well as erasing or manipulating images for you. There are different models involved in catering your different needs for videos, images, and texts, right? So it is not the case that you throw everything at LLM and it is able to do, although they are, as of now, they look like it, but behind the scenes there are some specialized use cases that they have cracked up, that they have trained these LLMs with it. Okay. The topic here is that today what we want to discuss here is, how does AI learn, right? How does this AI learn? We have what we discussed so far, that when we need, sometimes we need to balance between rules and rules and a lightweight AI or the complex AI. But today we will be we will start learning how does this AI actually learns, right? So AI is, like I said, one more definition of AI I will be giving, and that definition is, AI is a huge mammoth size. It is a mammoth size statistical statistical data mapper. It is a mammoth size statistical data mapper. That is data mapper. That is, you should have, first and foremost thing, AI does not work without data. AI needs data, right? AI needs data, not just data. AI also needs to be trained. Without training, AI is zero. It needs to be trained, right? It needs to be trained. So it needs data, it needs good quality data, right? Quality data. It needs some quality data, high quality data, and it needs to be trained. These are two things that we all have been hearing, I mean, everyone has been hearing all of these fancy terms again. And what actually happens inside? So in data, so soon we will be actually running our first simulation of training today, right? No programming as of now, but yes, in future we will be automating the same process of training via programs, right? Programs are here to automate the things, and obviously once our logic is fine, our logic is there, we can actually ask Gemini or Chat GPT to write code for us. It will write most of the code, but some of the quality code on the last amount of uh, reviewing and everything will have to be done by us, right? So they're again not perfect. So yeah, So we have data and we will have to train it. Now, what actually is happening when we say that they are being trained, and what is happening inside? What is a model we always see? What is that model thing? Let's try to discover all of those things, right? So okay, first let me actually just tell you some, let me show some data first to you. Just give me a second. Mhm. Okay, let me reshare it. Now, see, the data will be sometimes, most of the times, it will be present like this, right? This is some tabular data we have, right? Not all of the times the data will be present like this, but this is an example of tabular data, right? So here x and y is very simple as of now. This is very simple. What we are trying to predict is, or what is the data we have? Forget about what we are trying to predict first. This data is about the previous day temperature, right? The temperature, previous day temperature, right? We have previous day temperature and last 2 days previous day, that is n minus 1 and n minus 2 temperature, and n is today. These, using these three data points, I want to train a model that it should be able to predict tomorrow's temperature, right? Is it doable? Is it not doable? Now, a lot of times this is a sample data. Now, this is some good data to start with, at least. I mean, not a very complex data, but yes, I mean, again, not having a very linear relationship, right? Not having a very linear relationship, right? Uh, so what is, this is very simple data, and what we try to predict here is, if I want to predict that what will be the temperature tomorrow. So one process is obviously that what we can do is that we can write some set of rules. We can start with some set of rules, and we will just start that. We will start with some set of rules first, that this is how data, if this is what is happening, this is what it should do, and if this is not happening, this is what it should not do, and all of these things, right? Now, let me just take this data to our whiteboard screen.
Anand, is this playground available for us to practice later?
Yeah, I will. What I'll do is I'll host it on, the Invents AI website.
Okay.
I'll host all of these playgrounds there.
Yeah, even last week you showed us the 3D models.
Yeah. The only thing that I sometimes see, these playgrounds are easily copyable. So, like, I do spend a lot of time in preparing them. So sometimes, I mean, I feel a doubt that someone can easily copy them. So this is the only thing.
Okay.
Right. All right. So what is happening here? So here, this is my data, right? And this data is present. Now, like I said, what we have to do, that this data will be present here, and we have to train on this data. We have to train on this data, and this relationship, the relationship that is present here, may not be linear. The linear relationship is easy, right? Just as, let's say, your salary and experience. This is your experience, and this is your salary. I mean, you can assume it linear for certain amount of time. I mean, do not take it very literally, right? experience and salary, it is linear. I mean, obviously you would say that, yeah, if you have 10 years of experience, that this is something what you can expect. If you have 20, if you have 25, to become a CEO, you will need 35 years of experience and XYZ and blah blah blah, right? And all of it. Not every relationship is linear. So okay, this we can easily do this rules, right? Do this thing using rules. But if the relationship is something like this, you will not even know that if this relationship even occurs or not. Right? In first lecture, I did talk of some certain examples, right? For an instance, and just talking about the real examples, that when depending on the weather conditions around the oil wells, right? Depending on the weather condition, fog conditions around oil wells. It's not exactly fog, but yes, the weather conditions around oil wells, it affects the prices of oil in international market. It affects the prices of oil because then there's a delay and all of those things happens. So it affects the prices of oils. Not just that, I mean, even the satellite images, what people used to do earlier, now they have banned it. In Google Earth, basically, it, I guess, not in Google Earth, but there is some way to obtain these satellite images, and these satellite images were simply giving the photograph of land, but they also used to give, uh, there are certain oil wells present, and oil tanks, sorry, and these oil tanks are, they used to be in open, and then if the oil tanks are empty, then basically it displays, simple, maybe the color of the tank, whatever it is there, maybe gray or red. Again, I have read this story, right? I have not seen these images. So let's say the red color, and if there is oil, it will display black. So obviously the oil reserve can be calculated using this thing. Now you do not even imagine that this kind of relationship ever exists in this world. You cannot even imagine, right? These kind of relationships do exist. Now when these kind of relationship exist, obviously you will have to switch to AI, right? You cannot, or you will have to switch to the modern tools, I would say, right? So this is the data, this is simple data to start with. This is the simple data to start with. Now idea is that in this data first, and on top of that, when you are till now, whatever you have been doing, mostly you have been calculating relationship between two variables, salary and something, let's say experience. Only two variables, right? Two variables. What about if there is some relationship between five different variables, or five different factors affecting one outcome, or 10 different factors affecting one outcome? Now the things go complex, right? And this is where this whole science, data science and everything comes into picture, right? So okay, I was at data. This is my data. This is x1, x2, and x3. So x1 is basically like n minus 1, or my temperature for 2 days ago, and this is the temperature for 1 day ago. This is the temperature for today. And what I want is, I want to predict the temperature for tomorrow. That's it. This is a very simple example to start with, and the outcomes will not be accurate, comparatively accurate in this case. Slowly, because for now the whole point is to understand how is this AI learning. So now let me actually first try to explain it manually, and then we will be, uh, I have different playgrounds to understand how this is happening, and then we will even try to replicate the same thing on Excel, right? We will try to write the formulas and we'll try to replicate it on Excel, right? So what is happening? Like I told again, it is a big statistical mapper. It is a big statistical mapper. Mapping engine. It is a big statistical mapping engine. So what is happening? So basically, there will be, let's say, two data points. For easier understanding, let's say there is two data points, and as of now, this is x1 and x2. These are two data points. Actually, ideally, we can start with only x1, right? X1, and I should have training data, that is y1, right? So I should have x11, y1. I already know this is the outcome of x11, x12, y2, x13, y3. So I already have this data. So even if you see here, this is my data set, that is already the source of truth is already present. If there is no source of truth, there is no AI happening, right? There is no AI happening. So y is already present. My predicted value is already there. That if this was the temperature of previous 2 days and 2 days, so this is the temperature for tomorrow. If this was the temperature for last 3 days, then this is going to be temperature for tomorrow. This is the temperature for last 3 days. Then already my source of truth is present with me, first and foremost condition, and hence there is no learning, there is no AI learning without the data. There is no AI learning without the data, right? So we already have this truth. Next, welcome to new word, next step from rules, that is weighted learning. Weighted learning, something wonderful, very wonderful actually. And when I discovered this concept a decade ago, I mean, I was just blown away. And then what I observed again, I started observing all of the intelligent systems, including the intelligent system of nature and everything, they work in a more complex but in a similar manner, right? Weighted learning, weighted learning in the sense that between, if I have to map from x1 and y1, what is the difference, or what is, there has to be some relationship between them. And let's say that relationship is, I would call it, let's say delta t, right? So there will be a relationship saying that x1 into delta, or I will call it delta w, right? Weights, since it is about weights, so there will be some delta x1 into delta w is equal to y1. Now this is again, like I said, this is just two variables we are talking, right? X11. Similarly, there will be some x12 into delta w that will lead to w2 results. Obviously there is going to be something. Now you see, if you observe x13 into delta w is equal to y3. What is this delta w? AI is all about finding the right weights. AI is all about finding the right weights. Now, and again, I have explained it in a really simpler manner. This is just a scalar data. Scalar data in the sense that is simple 1, 2, 3, 4, 5, right? Your data can be scalar. Your data can be group of numbers, right? 5. It can be group of number called as, start calling as vectors, or your data can be various other formats. We will discover that. We will discover those things. We will discuss those things. This all happens that numbers may occur in single value, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or they may occur in some uh, pair, two pairs, pair of three, pair of four, right? Pair of four. Some data may be represented in some pairs. And then there are some advanced format also. So this is the whole idea. This x1 can be really complex data, really complex data, multiple dimensions data, multiple dimensions. I do not want to confuse you here as of now, but just be relaxed and just think of that, some advanced data structure, some advanced data structure, or we are talking about some 100 different parameters. Now again, when I always say about, see, there is just one parameter here, there is x, it is a scalar. When I have multiple parameters, multiple values in the sense, parameters in the sense, on which we will be learning, on which we will be learning. Let's say x, as of now, I only talk about temperature. Let's say I have multiple parameters like temperature, I talk about humidity, then I talk about something else, temperature, humidity, and wind force, So now I have collection of data. I have some data that is telling me more amount of information, right? So always remember, again, this word is actually somewhat misleading. Multiple dimensions. Although since we as a human are very much fascinated with lot of fancy and sci-fi terms. So a lot of these terms are actually most of these terms are actually sci-fi itself. You know, under the hood they are comparatively simple concepts. They're comparatively simple concepts. Now if I just tell you that, okay, dimensions doesn't mean the dimensions like what you have in your head, the definition of English. As of now, just stick to the definition. It is collection of numbers, as simple as that. It is collection of numbers, and it is only going to be collection of numbers throughout the course, throughout the whole AI. It is only going to be collection of numbers, right? So dimensions is, as of now, this dimensions is not the right dimension that we talk about. We can't even imagine, we can't even imagine what is four dimensions. So then basically they took out a way saying that, okay, you add one more uh, uh, layer of data to three dimension and we will call it four dimension. Now this is only the, but actually what is four dimension, how does it exist, and what it will be like, we cannot imagine it. I mean, as of now, humans and our computers are not able to demonstrate that thing, right? So yeah, we may talk about, there is a if you try to read some article and everything, obviously everyone has an aim on LinkedIn and everywhere. They want themselves to be shown as the most intelligent people. And how do you become more intelligent? By using these fancy terms. Under the hood, they are simple things. They're simple things, right? Right. So collection of things, right? These are collection of things and collection of data. Now again, the whole AI, this magical AI, this whole thing, how does this magic comes into picture? That yes. So basically, again, I will again come here. Now let's say in one more example, I have some more data, and this time I have some data about, you know, uh, let's say again I will take temperature. I have wind direction, wind direction. I have about humidity, and then wind direction, humidity. I can take something else. Uh, maybe the amount, the intensity of sunlight. Again, we'll have to measure it some way. Intensity of sunlight, some way we'll have to measure. And we have some data, right? T1, T2, T3, and wind direction, WD1, WD2, WD3, and humidity H1, H2, and H3, and sunlight S1, S2, and S3, right? Let's say we have this data. This is my data set. We call this thing as my data set. We call this thing as data set, right? Now, if I have to train on this, now again, like I said, this time it is not single variable. And what is my why? What is my target? Always AI will work on my trainable parameters. These are my trainable parameters on which I will decide my target, that will it rain today or not? What is the probability of rain? Probability of rain, right? If you see, I do not know now the Android phones, they display this probability of rain or not, but earlier they used to give this notification that there is 50% probability of rain at this time. So basically what is happening, this is happening behind the hood. Not just these four parameters, they might be using even more parameters. And if you remember 4 years ago, their accuracy was horrible. I mean, they were mostly wrong. But down the line, what this did is they have more data now, and gradually they have started to, I mean, I do not know, they have increased the data, or they have more amount of data now, but gradually their accuracy has increased. Initially, the accuracy was very poor. There used to be like there is a bright sunlight outside, and it used to say that it's raining. It's raining, right? So this is data, and there has to be target. So always this is my training data, this is my training data, and this is my target data. Target, it will rain today or not, it will rain today or not. So if it is going to rain today, let's say, if you can again model this data into multiple ways. If it will rain today 1 and not rain today 0, rain today 1, not rain today 0, this is one way. Or you can put it into numbers, that there is 95% chance it is saying that it will rain today in numbers. This time it is, maybe this time you have gone into probability, it is 35% chance that it might rain today. This time it is 75% chance it might rain today. This time it is 15% chance it might rain today. So you can take any of the ways depending on the requirement of the application that you want to build, right? Depending on upon what application do you want to build, you can just take on any of these things, right? Okay, we have this. Then second, my complete data set, one training data set becomes T1, comma WD1, comma H, comma, sorry, not, comma H1, comma S1. This is my one training data point. This is my one training data point. This one training data point might have one weight, or it might now have multiple weights, right? Again, delta W1, comma delta W2, comma delta W3, right? Again, now I have multiple weights. I have, since I have multiple variables, I have multiple weights, but the whole equation remains same. The training data into delta W is equal to Y, target is equal to what it is equal to, it will be equal to some target. Target is my let's say rain probability, right? Rain probability. So this equation becomes this. Now how does it actually learns? So it learns just the way you learn, that is, you learn from your mistakes, and so does AI learn from the mistakes. I have a very good example before I go further into it. Just give me a second. Okay, I guess I have. So I have lost that PPT. Anyways, we'll continue here itself. So the example says that, let's say you want to build a recipe. You are trying to build some new Mexican, Italian, or Chinese recipe, or a mix of them, right? And you just want to crack something big. You want to sell it somewhere. But then, first and foremost thing, uh, you will have to. What you first you will do is, first you will just try, right? You will collect all your ingredients, right? These are your ingredients. These are your ingredients. You will collect all of these ingredients, and then your output will be your dish, right? Your food dish will be your output. And then someone has to test it, right? So you will taste it. You will taste it. And then, or you will ask your friend to taste it if you are too worried how it will taste like. And then either he will say you bad words, or he will say you good words, or he or she, right? And then based on that you will decide that, oh, I maybe the salt is more, this ingredient was less, this ingredient was. So basically here the target is fixed, a delicious dish that will taste like maybe more salty or tingling flavor or whatever the flavor is, right? This is your target. And to reach that target, what you will have to do is, you will have to first, you will have your input, right? And what is the ratio of those ingredients is your weights. What is the ratio of those ingredients is your weight. And it will produce some result. It will produce some result, R1. And this is the true value, the result, the truth. You already know that what your truth values are, right? The result, this is the true value, T1, the truth, T1, right? Now, what is the error between them? Error between them is truth value minus R1. Truth value minus R1. This is the gap you still have, right, from getting to the right value. So what you do based on this T1, I will update my weights. This was weight W1. I will update my weights based on this error. So now, based on this error, I will update it to W2. I'll say that, weight, you need to update. So I into W2 this time. I have updated my weights. I've updated my weight is equal to R2 this time, right? I have new result because my weights were updated, and it will produce a new result. Target T2, sorry, target T2 is already present. It has produced a result R2. Now the error is T2 minus R2. T2 minus R2 is the, uh, now what again I will do? I will again go ahead and update my weights as W3. I will go ahead and update my weight as W3. Then what is happening? Again, ingredients into W3. Again, it will. This is the training process. This is the whole training process of finding the right weights. This is the whole training process of finding the right weights.
Anand, quick question.
Yeah, yeah, sure.
Yeah. So as we have to, in order to train the data, right, we have to find the right samples. And also, I think the size of the data also will play direct proportional to the accuracy, right? How much data we feed it
Depends
to.
on how complex relationship are you trying to find out. If the relationship is pretty simple, then obviously even 50 samples would do. But
Okay.
again, if the relationship is pretty simple, no one would use AI for that, right? That's
Yeah,
an
simple
overkill.
rules, right?
Right?
Yeah.
Yeah. So obviously, yes, good amount of sample is definitely required. For training anything, like let's say if you're trying to train an recently, my most recent model which I was trying to train, I did train. So again, a common finding that I have, good quality 5,000 data points is more than or it uh, overpowers, or it is more accurate than 50,000 poor quality data points.
Yeah.
The
The noise,
quality,
right?
right, the quality of the data really matters a lot. The quality of the data really matters a lot. There are startups nowadays that simply what they do is they just are uh, creating data and selling the data, right?
Mm-hmm.
And even that data is, I mean, not all the data even that we purchase after paying the money is accurate. So all of the AI area is actually facing this data problem big time. You know, if you are able to prepare the right data, I mean, like I said, you have almost cracked 70 to 80% of the problem. Just preparing the right data cracks most of the problem. So yes, sample size, the right sample size and quality data is something that matters a lot.
Okay.
Right,
Yeah.
right.
Thanks.
Yeah. So this is the process of training. This is the whole process of training. This is what we call training. This was my data set. Training is, so how do we define training here? So we can define training as, training is the process of finding, training is process of finding
So
a
another
right,
one question on data
right,
also.
right,
How do we identify this data is actually reliable or not? If we train the AI, right, based on the data, there
right.
should be possibility your data should be wrong, right?
There are various analysis ways. I mean, there are various ways of analysis. First, we would discover them as we go ahead. That first, when we load the data, there are certain visualizations, there are certain checks that we should do before sending it for training, obviously. And many a times the data is being prepared manually. Most of the times, let's say if I want to do this thing, then obviously there has to be certain correlation between them. There has to be certain correlation, and sometimes what happens is, this is a hit and trial method. In many a times you will have to collect the sample, and you will have to do your due diligence and analysis, and then you will have to try that if it works or not. Again, and like I said, this is a kind of somewhat research and development, that you collect some data, you tweak that data, okay, it might work, and then again you tweak something in the data, then it may not work at all, and then you tweak something, and the accuracy increases up to 80-90% or something like that, right?
Okay. So in this process, a human also be involved, right, to get this proper data and this.
Sorry, can you say that question again?
To validate this data, human process should be there, right? It should be not be.
Yeah. Absolutely. This whole process requires a lot of human attention. I mean, this whole thing, people writing LinkedIn posts that humans are not required here and there. It is absolutely rubbish. These guys have not built even a single model themselves, not even put a single model on production. So yes, uh, it requires a lot of, and it is actually very time consuming, and it is very brain consuming. Not, I mean, it is a really frustrating job sometimes. When you are trying to crack something big, you keep on looking at the data, you keep on tweaking the data, and it doesn't work. Sometimes things don't work for months. And sometimes you'll have to, after working for months, you'll have to scrap it down, that okay, maybe this doesn't work. All of the good examples that we see, these are the use cases that have worked. Now there are millions of use cases that have failed,
Mm,
which we do not know, which we don't talk about. So
yeah.
these use cases we just hear about, we just use. These are the use cases that have worked. These are the use cases that have been successful. Right?
Yeah. Right.
Well, cool. Right. So the whole process, like I said, training is finding the right weights. We just have to train to find the right weights, and this whole science is going to be that only, to find the right weights. And you believe this whole science is a big science. As the data grows complex, we will apply some very complex methods. First, the process goes, first we will be uh, like creating data. First and foremost thing, it goes as creating the data, right? Now, just an example of creating the data, like back few years, there was a lot of, and that will happen in future, that radiology, AI is able to predict when trained right with the right data. AI is able to predict some things that even the MD doctors are not able to predict after looking at the proper report, not just reports, but it's about the X-rays and MRI scans and all those scans, right? So the AI has huge amount of, a lot more accuracy as for those medical. I mean, just this one small example, but as of now, we still do not have enough amount of data that we can start using them even assistants, because obviously now as the time passes down the line, after 4 or 5 years, when we have lots and lots of data available, then maybe even today, you can, I mean, if you go ahead and consult with your report with any chat gpt, they are able to tell you fine. I mean, they are not excellent, they cannot replace doctors and all of those things, but down the line, after 60 5 6 years, they might, or even a shorter time frame, with the right amount of data, they might have better accuracy than humans. So yeah, the only thing that is basically barring us is data. And even with the LLMs, we are in an infinite loop. That is, what kind of loop? Earlier, LLM was trained on data from internet, right? All the data was from internet. So initially, when there was no LLM, all the internet data was written by humans, right? So okay, it made sense. The LLM was trained, and then what started happening? All of the data is itself created from LLMs. So now LLM is consuming its own data that it has created. So this is what I mean. Few months back, I mean, there was a tweet from Elon Musk that we will start writing all of the things. I mean, we'll hire lots of team just to write all of the data so that LLM starts understanding all of it, right? Now, nobody knows what is happening. So yeah, I mean, why all of a sudden we are not seeing the right spike in the accuracy that we were seeing in the earlier days? Because there is limited amount of data now, and data creation is a costly process. It is not an easy job. But yes, if you have the right data, you can crack the right thing. AI is just after that 30%. It is 70 to 75% of it. The game is about data. Then after that, it is 25%. The AI is about 25%. So in fact, even if you have high quality data plus low quality AI, low quality AI. I mean, the right word is not but low quality AI, but lightweight algorithm, lightweight AI. These results are still, it will be greater. This result will be greater as compared to low quality data plus very heavyweight AI. So this result is going to be not right. And although this will consume a lot of money and all of those things also, but this will always win. This will always have a win. So here the whole dominance is about data, because data is the whole delta that weights learning is going through. It is going to be that process. The better quality weights we are going to have. Right. So training is this process of finding the right weights. Right. Now the time is that we start with very, very, very baby example. How does this happens? And believe me, this is nothing new again. Uh, if you recollect in some of the problems here and there, this kind of solutioning, some of you might have done. Some of you might have, the kind of delta you trying to find out, and then you trying to, and hence AI is not absolute also, because it is about weights. So AI is about coming near to the accuracy, and AI may not be completely perfect. Obviously, with data, when it has more amount of data, it can be very much accurate, right? Okay, so now it's time to basically first let me show you a demonstration, then we'll switch on to, if time permits today, then if not tomorrow. Okay, so what I have done now, there is no fancy mathematics involved here. It is just multiplication, subtraction, and addition. This is the only mathematics that will be used here. And since I say this, even the advanced mathematics that is present, the maximum maths that is being used is about slope, finding the slope of the curve. That is the most of the times that is being will be used, where a lot of complex mathematics and everything might be used. Now, if you pick up this example from any book, they might say that, they might have used those curved notations called as derivatives and everything, which makes things look complex. Now, is it the case that derivative will not be used? It will be used, but derivative is just about finding the slope of a curve. That's it. Derivative is all about, like I am saying it again, derivative is all about finding the slope of the curve. I'll come to that later. Much of the mathematics, we are still struggling. There are curves, like we have already seen linear relationship. Then there are lot of non-linear relationship, right? We have just for an instance, we have, let's say for instance, we have this linear relationship, then we have this non-linear relationship, then we have this non-linear relationship. Now the derivative is all about finding the specific slope, and it is very relevant in case of non-linear relationship, right? Derivative, the complex derivative that we have been, it is all about finding these slopes. That's it, actually, that's it, right? So and then there are some simple concepts around it. Mostly we will be using this because our weights are going to be, we will soon start visualizing our weights. We will soon start visualizing our weights. and this is how our weights will look like in 2D. So what we want is we want to find out the lowest point. We want to find out uh, maybe the error or the weights that fit the best. The error, let's say if we are trying to find the error, then we'll try to find out this. If we are, this is the lowest point. This is the lowest point. So we'll try to find out this. So obviously then this becomes that, okay, this is how we use, and this is what basically derivative means in terms of all of these slopes. Like, coming back to the main topic. Right. Okay, so this is my data here, and the data is pretty simple as of now. The data is that I have x1, x2, and x3. That is, I have data of previous 3 days temperature. Like I said, I have previous 3 days temperature. This is of temperature uh, n minus 1. Like, maybe if today is Saturday, this would be of Thursday, Friday, and Saturday. That's it, right? So this is how data is present. This is the actual data that is present. This is the actual data that is present. What it will do, first step, it will try to calculate y prediction or y hat, right? This is y hat. A y with a hat is a y hat. Please do not be confused with any complex calculus notations, right? When I actually started learning, I was very much confused because I used to find all of these derivative symbols here and there, and then but gradually when I cracked down, I mean, these are not so simple. These are not so complex concepts that anyone should not be able to grab it. I feel, unfortunately, the mathematics has been taught to us in the wrong way. I mean, no visualization with the maths means no maths, right? And hence we started not liking mathematics, right? But soon you will start. I guarantee you, at least if you by the end of this course, what you will like is you will at least try to appreciate mathematics, and you will all those fear of maths will be just washed off. So why is nothing, y hat, it could have been anything, y dash, y anything, just y hat, right? And then error is just y hat minus y is your error, as simple as that, right? Simple thing, simple mathematics. This is it. And then what I try first, I'm doing this through a playground, but I will be doing it on an Excel right before you, so that it doesn't seems like, okay, what has happened in the background. I will be doing it in the Excel. If the maths is so simple, then it should happen on the Excel, right? All right. Let me first, step one, ignore all of this. Now, not because there is anything very fancy going on here. Basically, whatever I have explained, only that thing is going on. All these numbers, when put on together, might be sounding complex. But then what has happened? I will just 3, 4 rows. And what has happened? The same thing what I was explaining has happened. Basically, what has happened? Y prediction, and 27 minus 9, right? Or 9 minus 27. Then again 567 minus 25. Again 2, 25, 506, 27. And this keeps on happening. This is one data sample complete of 270, I guess 270 or 250 points, right? This keeps on happening for certain amount of time. Let me finish this off. Play one epoch. Okay, okay, okay. All right. This process, now obviously this process, if we keep on doing manually, if you have 10,000 data points, I mean, it might take you forever for doing that. Or even with Excel, Excel is tool for starting phases, it is right, but yeah, for advanced phases, obviously it won't work. For that, we will have to write some small scripts. So okay, my error is still very high. Actually, my error is still very high. My right, and if I try to predict some data, this data is not making any sense. So what should I do? I should again train with some more data, with some more epochs. I mean, some more rounds. Epochs means rounds. How many rounds are we training the same thing? This is what epoch means. Let it run, let it run. Okay, the error is still very high. Actually, the error is still very high. The idea is to minimize the error. The idea is to minimize the error. Since I have done it one by one, so it might take some amount of time to minimize the error. So we will keep on performing, we'll keep on performing this whole process.
Hey Anand, one quick question.
Yeah,
Maybe it's a stupid question, but like since these are numbers, right?
right.
So every time we go through this correlation logic, right?
Right.
Is it not supposed to be a constant output?
Sorry, which correlation logic? How?
I mean, the currently what system is doing, like it's going through x1, x2, x3, and y
Correct,
is output, right?
correct, correct.
Trying to find that weight, right? Now, this being a numbers,
Right.
why it is not being a constant every single time we run that, right? How it is adjusting in the backend, right?
Yeah. Okay. So let me just finish this up and then I'll just jump to this. So yeah. So what is happening here as of now? It is trying to train. It is trying to train. It is trying to train. Now let me go back to the previous slide once again. So what is happening here? If there is x1, x2, I'll just take the screenshot and we can talk on this. Right. Now here what is happening here? Okay, this is my data. This is my data we have, right? And now what has happened basically x1, so there is this data x1 again, like we coming to the previous point again, that we have this data x1, we have this data x2, and we have this data x3, right? Now this x1, x2, x3 data, so basically what is happening, so behind the scenes what we have done is we have w1 which we will do in the excel also ourselves. We have weight w2 and we have weight w3. There are three weights per variable. So this is what we have done. Since I created this, so I know this. And even in the excel also we have the same data. So then x1 into w1 plus x2 into w2 plus x3 into w3. Then there is one more bias, we call it bias. Bias is again one more variable to adjust for non-linearity, in the sense that if I am just using that, so this is a, you can, for now you can think of as noise, that if there is any noise also, then also my data will adjust. So this all is equal to y hat, and we will be using this formula in the excel like I said, but I guess today the time will be limited, so we'll be jumping on to that example tomorrow. And it is okay if we spend the time, good amount of time in learning this part, because this part remains forever for us. This part will be forever for us. And the moment, even with this concept, once you learn this whole concept, you go back to any of your concept, suddenly you start seeing that you have just jumped from rules to dynamic rules, right? So this is my y hat, this is my y hat, and this y hat, this is my y hat predicted, and this y hat is y is my actual. So y, now this is my actual, and y hat minus y, this is my error. Error is equal to y hat minus y, right? This is my error. So basically what we are doing is, what we do is, if there is any negative or positive number, we actually ignore that, right? If there is any negative 15, that also becomes 15. If it is positive 17, that also becomes 17. If it is minus 23, that also becomes 23. So we are just using the magnitude. We will just use the magnitude. We will not use any of uh, the signs. Basically we are ignoring the signs. Now this is what is happening. My idea is my error should be minimum. If my error is minimum, right, obviously if my error has reduced a lot, right, then obviously it means my predicted value and my actual value are now very close to each other. And this we will do. I mean, not just saying it in the example, but we will do that, right? I guess I'll have to just change this feature so that it keeps on running till 2 to 3 minutes, and once it runs for some 5 to 10 or 20 rounds, it will happen that my predicted value and my actual value will come very close to each other. That is, my predicted value might be uh, 28, and my actual value might be 27.5. And how did it happen? Because my error, I brought down my error, right? So I will keep on doing this, I will keep on doing this till my error does not comes down. Now, is it the case that always your error will come down? No. If the error is not coming down, then obviously then there could be a problem that there is no relationship at all in the data, or there could be another problem that we might have to include more amount of data set, right? We might have to include more amount of data set. And hence the advantage of these live sessions is, like, I do not bring anything ready made, that okay, I pick up any ready made thing and I say that okay, this is how it runs and all of those things. I will be doing it right from before you, so that you and I'll be getting stuck in between. There will be some days our models may not run at all, and there will, but I guarantee that whatever is not running, I'll make it run. And there will be some days we debug it live, and all of those things might happen, right? So I hope I have answered your question.
Yeah, Anand,
Yeah.
that bias one should be in negative, right? Because we should less bias from this figures.
So it is not about negative or positive. So basically the whole idea is, even if you remove bias, it will work. But usually what happens, we will soon understand, basically the whole idea is of linear and non-linear learning. So basically if the relationship is non-linear, then basically this will not, we'll have to include that. And later on this equation becomes actually the activation function. So it has nothing to do with the negative and positive one.
Okay.
So,
Jitu, is your
Anand,
question answered?
yeah. I understood the way it has been managed in the back
Right.
end, the way it has been calculated. So,
Right.
so with the each iteration,
Right.
like it tried to adjust the weights to be able to go back to the actual value, so that error will be less, right? So that's how it does in every iteration, right?
Exactly. Right.
Okay. Okay.
This
Thanks.
is what it does now, and this is what it will do forever.
Okay.
This is what AI is. The
Mhm.
only thing that will keep on getting complex is the data, right?
Mhm.
Here you have this tabular data. In future, it will be images, it will be videos, right? It will be natural language. So again, the uh, machine will understand only numbers. It will not understand characters or nothing. It understands only numbers. So we will have to study a lot of different ways to make that data, uh, you know it should make sense to machine, right? If there is a video, there has to be a way that you have to represent that whole frame into numbers, and we'll do that. If you convert one single image into Excel and you just encode the color encodings, so that Excel can show you the complete image, right? All of that thing I will demonstrate it. So this is what is happening throughout the whole process. This will keep on happening throughout the whole process. This is what is learning. And don't worry, it is not yet over. We will be doing it practically through an Excel. We'll be putting this data on the Excel, and then we will be calculating those numbers, and in the end our error should come down to zero, right? Obviously on Excel, I'll have to find out the way so that these many rounds happen, right? But yes, on the Excel we'll understand the logic once again, and then we will, in here itself, we will bring down this loss to minimum. Actually, I have one demonstration more just before I wrap up for today. Hold on. In the meanwhile, if anyone has any question, kindly bring that.
So Anand, the
Yeah.
weights that this model uses, right? So it's also dynamic, right? So it changes in every iteration, and it
Yes, yes,
tries
yes.
to find the correct weightage
Correct,
for
correct,
each of
correct,
these
correct.
variables. Okay.
Weight hunting, yes. Weight
Okay.
hunting is the part. It's okay to not understand everything for the first time,
Mm-hmm.
because I do understand that when everyone coming from that background, that okay, we have been working on if else conditions, the fixed conditions we have always been working on, and we suddenly get exposed to something that is in probability, and it is a skewed logic. I mean, it is not a very general logic, right? It is a skewed logic. So obviously, it is okay. Soon, as we see more examples step by step, as we see lot of demonstrations, this happening with images, videos, natural language text. So soon we will understand it, right?
Yeah, yeah,
And then
Yeah.
just one doubt, like, is
Yeah,
there
yeah,
a possibility to tell the model, like, before starting the training, the range of the weights that it should be, like, instead of
yes,
starting at
yes,
very
yes, yes,
high?
yes, 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 yes. That is again, weight initialization is a different topic altogether, and there are ways to initialize those weights. How should we initialize those weights?
Okay.
Now, just an since you have asked a very good question, so just loss is decreasing. Loss is decreasing. Slow by slow, loss is decreasing. Now, if I use now this is another demonstration, right? If I use something as my 28, and I will use 27, and my x3 is something 25 or 26. Try to predict. It is 27.706. I mean, not a complete nonsense, because the loss has been brought down. Okay, now coming to your question, this is the whole point. The weights, if you have the weights that are already to the minimum, means that is your model you already have, right? So if you have the chat GPT weights, now even if you go online, and even if you Hugging Face model weights, so it's all about weights. So if you see all of these models, these are actually weights. Model weights fixed enables from gradient. This is used for fine tuning while keeping the model weights fixed, right? So yes, everything is weights. If you already have the right weights, and these right weights are those magical numbers where the magic happens, that magical balance where the magic is happening, right? I will try to put more demonstrations tomorrow. uh, but have I answered your question?
Yeah. So we have the weights, then that is the what we are actually looking at finally as the result.
Right.
Yeah.
The weights is actually everything. The weights is the model, right? It and these weights can be these three weights. In our case, we just have these three weights: W1, W2, W3. In other case, these weights will be huge. I mean, trillions of weights. These weights occupy like 500 GB of space. But inside, these are complex numbers. In this
So
complex,
it's like,
not
before
like
training, it's not possible for us to even have a guess estimate of what could be
exactly.
the weight.
Exactly. And always, the model will always and always learn, I mean, predict using multiplication only, right? There are some here and there operations more, but yes, input into weights is equal to output. I mean, this equation remains most of the time true. There, if when there are some exceptions here and there, we'll cover that. Have I made it clear,
Yeah.
guys?
Yeah.
Anand, so like
Yeah.
sometimes we hear that like there is a certain model, it trained on certain million parameters or
Yes,
certain billion parameters.
yes,
So
yes.
these are the our x1, x2, and x3, right? These are the parameters.
W1, W2, W3, and bias,
Okay. These are
right?
the
Parameters,
parameters. Okay.
right.
And how about these tokens? Like sometimes we hear that like you have this many tokens, you consume this much tokens
Yeah.
by using this.
Tokens so this token usually comes in LLM vocabulary, right? So tokens is the number of first actually tokens is actually in technical terms, tokens is your model, how many words it understands. First and foremost thing, this is the token vocabulary, right? How many words your model understands.
Mhm.
I may build a model, it may understand only 100 words because my data set had only 100 words,
Mhm.
right? Now Facebook may have lot of different models. Now it understands smiley also. That is also again in the vocabulary. That is also a token, right? And it may understand some slang words also, right? That they may have it in the vocabulary. So token is the minimum kind of word. It is the smallest word that the model understands. For now, I mean, just for making you understand. But these tokens we'll be creating ourselves. We'll be fine-tuning our model with it. So basically, the smallest data point inside the data set is token, and token is mostly valid in terms of text data. Right? In text data, the smallest word we call it as a token.
Okay. Okay.
Right?
And this is what you showed us today, right? This is a predictive model, right? So it might be using certain formula, right?
Right.
And if we change the use case, we might need to develop some other formula as well, right?
No, no, no. The formula remains the same. Just the
Okay.
last things vary. Now, how does it varies? Now, let's say if I want to predict if the temperature will be winter or summer, then you can apply, I mean, just first solution is you can just apply if else, that if the temperature is more than 20, then it is summer. If the temperature is less than 10, then it is winter. But
Okay.
even from model perspective, there is one more formula that will be attached after it that makes it in classification category. But
Okay.
the core idea will always remain the same. Core idea always remains the same. It is
Okay.
actually we start playing with the bias, that bias B thing, that noise thing. What I called noise today is not actually the noise, right? We start playing with that.
No, like I mean, so currently our model is built to predict the temperature, right?
Correct.
Tomorrow, if our application change and I want to predict, let's say, stock price, or let's
Right.
say whether rain probability and things like that,
Correct.
right?
Correct.
So
Correct.
even so, our application or use case has changed, right? So in that case, I may need to build a new formula, right? Or I can reuse.
Formula, like I said, formula will not change. Data size, data structure will change.
Okay.
Now, formula, when you have, let's say you have now 100 different X parameters, right? So your formula becomes more complex,
Okay.
right? And then there is basically billions and billions of neurons. That is basically multiple the same formula gets calculated almost thousands and millions number of times, right? And this is where the whole magic starts happening. Basically, this is just one point that we are discussing. When we go with the real models, this whole calculation takes place in at least million to billion number of times.
Makes sense.
Right?
And so basically, so this is predictive model, right?
This is
When
predictive.
it comes to generative model, so it may function differently, right?
Now, isn't it generating this number 27?
Yeah, but
Is it?
it's like in a way it's generating, right? But like we are predicting the
Generative.
template, right?
Yes.
So let's say if I need to generate, let's say, new image, right?
So when
So
you, so just a small thing. If an email can be represented in group of numbers, right? Or no? Right? Let me switch to whiteboard. Give me a second. See, like I said, many of these concepts are good and sometimes they might confuse you. Where is my whiteboard? Okay, where is it? Correct. So basically, see, you're always actually, if you see, you have been generating numbers always. 5 into 10. Are you generating any new number here? Is it? 15. You generated a new number? Now, this is from a very layman perspective, I'm trying to tell you, right? Now, what is happening? You said that you want to generate an email, right? Generate an email. As of now, what you are doing, input is going to model and it predicts a temperature, right? It predicts one number, right? For email, it will require some 20,000 numbers to be generated, right? Right? Because see, it is not going to generate text. Model does not understand text. It doesn't cares about text. All it understands is numbers. So basically, your generative model, it generates big group of numbers.
Okay.
0.23, 0.45, 0.67, and then we convert those numbers into text.
Text. Okay.
And this is what becomes generative.
Generative. Makes sense. Okay. Thank you.
Right? All right, team. Any other question? I like the questions you guys ask. I mean, I like the enthusiasm, and it like I also get the encouragement to show new demonstrations and everything. All right. All right, guys.
Efforts, and thank you very much for the session.
Yeah, most welcome, guys, and thanks for joining. Let's catch in tomorrow, right? And tomorrow, same time, 12 o'clock, we'll catch in. Thanks, and have a nice Saturday. Bye.
Thanks.
Thanks, Anand.
Thank you.